Okay, wow, you're all so attentive and all. Always love having that after lunch spot where you listen and you get lulled and you fall asleep. Well, we'll try to avoid that and try to keep my voice going. Thanks. As introduced earlier, I'm Victor Borden, come to you from Indiana University, which is in lovely Bloomington, Indiana, about 500 kilometers south and a little east of Chicago. Indy 500, maybe some of you know that race. We're a little about 50 miles southwest or 70 kilometers southwest of there. I've been coming to UKZN for the last few years, working with staff from various areas to talk about how they do evidence-based practice, how they use data, research, analysis. And early on, Ruby said, let's call this analytics. And I said, you can call it what you want. One of the problems I have with analytics is because it gets into this frame with prediction and things where it's like the numbers will tell you what to do. And turns out numbers don't speak for themselves. We actually have to speak for them. And it's not so much what the numbers are telling you, it's what you are thinking the numbers are telling you that's important. And we tend to think different things, where different people come from different perspectives, so we think a lot of different things on it. We have different ideas. And so what we get into now is where those ideas come from and why they are so important, why it is extremely important to interpret the data and to do it with multiple voices, to have different people who see things different ways help interpret the data. Looking at the correlation of background information with compliance with a medical regimen, with compliance with an educational regimen, with getting through a program on time. Seeing that there are things related to it doesn't necessarily tell you anything about what you can do about it. Like I said before, if gender is related to something, what does that tell you? Well, it doesn't tell you anything directly related to gender, but it can tell you a lot about how genders are socialized differently or other, you really have to get into why is it that gender makes a difference? What is it about it? And so you actually start deconstructing everything behind it and trying to basically say, well, if I control for this, this, and this, then the gender difference goes away. So those are the things that must be causing it. Well, maybe, maybe not. There's actually no way to actually prove anything when you're working in this realm. So let's go through this a little and talk a little bit and have you think and talk about what is causality, why do we consider it, and how do we establish or support it? And the how part is really something I could tell you about different techniques and strategies, but really that's what you're trying to work on here with your projects, with your ideas, with whatever you're doing, is to try to think more deeply about what you think may be going on and how you would tell if that was what was going on or not. Because we tend to go with the data we have at hand, because we have it. But if it's not answering our question, then it's not very of much use to us. It's like the old expression, if you have a hammer, you think everything is a nail. But also, if you have a hammer, that doesn't make you a good carpenter. You need other skill sets about building. So let's go through this a bit. I have several humorous slides thrown in. I knew that Rondir would like this one especially. This shows you that there is a direct correlation between the decline in Internet Explorer, Microsoft Internet Explorer's market share, and murders in the United States. So obviously, there are a lot of crazy IT people going around killing people because of the frustration that Internet Explorer was causing in them. And once they got onto other browsers, this epidemic of rash killing subsided. This, of course, is, and by the way, if you really look at this graph, you see it makes no sense that the murders in the U.S. is 90%, 75%, 60%. Oh, no, I get it. That's the other side. That's the share, internet share. So, anyway, we'll have a few of these going forward. So, causality. Causality is about interpretation. What do we think is going on? And we know, I don't have to tell you, correlation is not causality, because you've heard that ad infinitum. But let's explore that, not just say that. So Randier also gave me this example. I have other ones we'll use in a second. We know that the number of fire engines that report to a fire is correlated positively with the amount of property damage that is done. The more fire engines, the more property damage. So obviously fire engines are causing property damage, right? So we should stop sending fire. Let's just fire burn out. So, you know, that's kind of obvious and funny, but not. We actually do make these kind of causal leaps from our correlations. Let's talk about something a little more subtle. Students who achieve higher grades in college make more money later in life. Why is that?
Employing people with mathematics, technology, engineering, mathematics skills, they will be successful. So if they get high grades in school in those disciplines, the chances of them succeeding in a career that demands those skills will ensure that they get...
okay, so they're better trained. So you might say something like, they learn more, and therefore they're better at what they do, they make more. Or maybe, sort of what Ruby was getting at, but not having to do with what the students do, but they come from more affluent and well-connected families. And that's both correlated with higher grades and with better wage outcomes. Or maybe students who get better grades in college demonstrate mastery of workplace rules. They're more compliant. They do what they're told to do, and they do it. They're diligent. And it's the diligence that makes for better paying jobs. Or maybe students who get lower grades are more likely to smoke, do drugs, and generally rebel against authority, which does not help in the job market. Lifestyle. Which of these do you think is true? Probably all of them. None of them and all of them, right? Welcome to human behavior. It is very multiply caused for all sorts of reasons. For any one person, any combination of these things may be working or not working. The affluence didn't, well, we weren't that affluent, but middle class. It worked well for my son, but apparently not for my daughter, you know. 1 for 2, that's not bad. There's someone to pay for nursing homes, that's all that matters. So we're trying to figure out in a very mucky area, human behavior. Generally, some of us are in maybe the climate change isn't directly, but there's a lot of human behavior behind it. And, you know, I have to apologize. I don't necessarily know your area very well, and I will stick to what I know well, which is higher education. But I think you can filter it and tailor it to the areas you're thinking about. So causality, we think, is about what makes something happen. And we'll talk about why that's important in a little while. But I also want to frame a lot of what I'm talking about in social science epistemology, which is not a single thing, it's multiple things. But if you talk to a computer programmer long enough and you're having several computer programmers, you lose sight of the social science side. Similarly, if you talk to social science people too long, you lose sight of the engineering computer side. So in social sciences, it's not simply what makes something happen, it's what we think. It's an explanation we think will help us understand what makes something happen. This is a relatively simplistic theory. It's a theory out there, the theory of planned behavior. Anyone ever work with the theory of planned behavior? It says to find out whether somebody is going to behave in a certain way, find out whether they intend to behave that way. Their intention predicts their behavior. But that's not the only thing. First of all, their intentions is made up as what they think of the behavior, plus what they think important other people think of the behavior, and also whether they think they have control over it. So it's a pretty simple theory, and it's highly predictive if you do it at the right level. And it's kind of one way to try and predict why someone will do something. And it can be useful, but we don't use it a lot because we're not necessarily, we're more interested in why they intend to do it than whether they actually do it, because that's sometimes beyond their control. But this is an explanatory system. Somebody, Isaac Eisen and Martin Fishbein, reading other people's stuff, said, I think this few things will help explain why people behave the way they do. Why did you hit that other person? Why did you take that class? Why, whatever it is. Well, I intended to take the class. Why did you intend to take the class? And this is their explanation. And it's actually a very popular theory, very simple. But as you can see, it's based on ideas of what causes what leads to what. A little reversal on the usual behavioral theory. It is very behavioral, but the rats are saying, it's a rather interesting phenomenon. Every time I press this lever, that postgraduate student breathes a sigh of relief. So he's conditioning the postgraduate student. And you thought it was the other way around. So in science, in social science, we use formal theory. Those are our systems of explanation. So they tell us not only how we think something will happen, but what we should look for. And that's very important, because whether you know it or not, there are certain things making you decide what to look at in the first place. And even if you don't think you're using a theory, something's guiding you that way to look at what you're looking at. Now, in the late 1900s, early 1900s, when positivism was coming out as the basis, and please, this is not my expertise, so if you know better, let me know, but Karl Popper and some other people around there were coming up with this sort of rigor of scientific method, the deductive-inductive cycle and positivistic ideas, and coming up with general truths that work across all situations, formulas, so on and so forth. And so you get something in chemistry, and I had to look this one up. I don't know why, actually. I had to look up an example. I don't know what the reason is. Any chemists? Well, you're sort of a chemist, right? Partially. Why does water turn red when phenolphthalein is added to a solution of sodium carbonate? Do you know the mechanism? A reaction that gives you another component that has color red or something like that. This is in one of these textbooks for children, turning water to wine, because they're clear things and suddenly the water turns red. But it's a known mechanism. We know this is why, because of the chemical composition of this and the solution and blah, 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 it turns red. So we have a good explanation. Well, like I said, in social science, we don't have such universal rules. We have constructions. We make up a version of reality that we think is a good version of reality. And we think it's better than other versions, or someone else has their version, and we compare versions and we see which one is better. How is it better? More predictive and simpler. Those are the two criteria. We can explain things complexly, but if something simpler explains the same behavior, why do it complexly? So what's important here is to understand all these ideas about what causes what are simply social constructions from a certain point of view. And there's no truth. There's no actual complete truth here. It's what do we agree we think is more or less useful for us to move where we want to move, for us to reach our objective. So easy objective for me is student success. Well, what do you mean by student success? Well, at least I want them to complete my programs. Okay, do you want them to learn something? Well, yeah. Well, how will you know if they learn something? Well, I test them. Doesn't that show me they learned something? Maybe, maybe not. Rondir and I were talking about this before, too. We have at the postgraduate level, there are pretty much no exams anymore in most, I shouldn't say that. Fewer and fewer exams. And undergraduates, maybe half our classes have exams, and the rest have assignments, term papers, projects, things like that. So when you study for an exam and you take the exam, do you demonstrate that you have learned the material? And if you come back 6 months later and are quizzed on it or have to use it, will you know it? Maybe, maybe not. Hard to tell. Well, those are critical questions that we're not very good at answering, actually, in some ways. But we can at least say, well, if a person learned it, they should go on, in some of our disciplines, they should go on to a career related to it. And if they go on and they're found to be a good worker and they do well and they have a great career, they must have learned it. Or they knew it before they came. Well, or they had the characteristics to learn that and also to do well. We don't really know, but that's not important. We just want good outcomes. And so I guess the real moral of this story is nothing is truth here, so therefore one way of looking at it is not inherently better than another way of looking at it. And getting people with multiple ways of looking at it together is always a good thing. Colleague Adriana Kazar, she's a very talented writer, and she's written a good article, To Use or Not to Use Theory, is that the question? And she talks about this a lot. What do we think theory is? Well, if you look at different people who have theorized on theory, they say similar but different things. Set of interrelated constructs, definitions and proposition, coherent description of observed phenomenon, organizing tool for facts, laws, and concepts, blah, 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 blah. Different ways to put it. Also, there are small theories, and theory of planned behavior is a small theory. And there are big theories. Big Bang theory, that's a pretty big theory. Psychoanalytic theory, Freudian theory, those are big theory. They explain everything, all because you got repressed at a certain stage in your life. Poor you. But she says, really, what this is all about is explanation. We're trying to get a handle on why things happen. And what makes a theory good is its ability to explain. And so when we mean explain, we're talking about cause. Why did something occur? And that's why cause and effect relationships are so central to so many lines of inquiry within a lot of different disciplines. So that's why we're looking at causality. One of our great philosophers in the United States, Yogi Berra, he said a lot of neat things in his life, like when you come to a fork in the road, take it. It ain't over till it's over. But he actually said, this is profound. In theory, there is no difference between theory and practice, but in practice there is. It's very profound. Just go home and think about that one. So, where social science has come, and I don't want to take the sails out of constructivists and situationists, because they definitely are they definitely exist. But what we're talking about here of using quantitative data in relation to evidence-informed practice is really in this realm of what we call postpositivist thinking. It's not positivist because we recognize that it's fallible. There's error. We predict risk. There's a chance we're wrong. There's a pretty darn good chance we're wrong, actually. If you actually ask for the error terms, you usually find these predictions are not that great. Human behavior is so complex. And not only that, the way we're putting the ideas together are fallible, too. And that's why we use this process of triangulation, where we say it's not just good to have one source of evidence. You need different sources of evidence. Egon Brunswick had this multi-trait, multi-method matrix, came up with a thing of saying there are different ways to go about measuring and there are different ways to look at it. And so you combine them both and you get something closer to a rich understanding. In the 40s, W. Edwards Deming. Does anyone know the name Deming? Total quality management, continuous quality improvement. He was in the United States. No one would listen to him, so he went to Japan and helped them revolutionize their manufacturing. And look at what happened to Japan in the 1950s. They went from a totally war-torn country to the largest, best manufacturing economy in the world, based on Deming's principles. And his principle was, it had a lot to do with precision and the Six Sigma and all that sort of stuff. But it was actually about learning about what you're doing through evidence and what he called profound knowledge, meaning you get to higher and higher levels of understanding by deeper and deeper probing into what you're doing. So that's what this is kind of about. Since it's fallible, we use multiple observations, multiple measures, and we learn and we keep learning. Okay, so that's kind of formal theory. But here's probably the more important thing. Some psychologists, George Kelly and some others, they have this thing called construct theory, which says you have theory in your head. You think the world works a certain way. And you rely on that theory because it makes things predictable and allows you to go about the world and not fall into sinkholes and have planes or lightning strike you or things like that, because the world has some order to it, or at least you impose order on the world. So whether you acknowledge or not, you have a set of beliefs and values that you think is the reason why things happen. And so when you're doing any sort of research here, part of the effort is to expose those beliefs. And it's usually where we find things that you don't, anomalies, things that you don't expect when they happen. That's when you start to question your beliefs. And you could do that intentionally, or that can just happen to you. So we all have theory guiding us. We all have things we think are the reason the world's why it is. Chris Argyris and Donald Schoen put this together in a theory of action. Says we develop governing variables, are these things that are the way we think things should happen. And we act based on the way we think. And then we see what happens. If it's what we expected to happen, we don't learn. We just keep going. If it's not what we expected to happen, we can learn in one of two ways. We can do single loop learning, where we simply adjust our action. So let's say you're trying to enroll more students into your program. Or, let's put it this way, you're going through your normal activities to enroll students in your program, and suddenly students stop. You're not getting enough students this year. So what do you do? Well, how do you get students? I don't know how you get students. Maybe they just come. But we sometimes go out to the local high schools, and we talk, and we hold information nights. And so maybe something's wrong with what we're doing, and we look, is there someone who's not doing their job right? Are we not going to right school at the right time? So you still think you're supposed to go to high schools and talk to students, but you just think you may be doing it wrong, so you change the high schools you go to, you change who you send, you change the time you go. Those are changes in action strategies, but you still think that's the way to do it. Double loop learning is where you actually question your fundamental ideas. And you don't just change your action, you change completely the way you think about it. Some people have attributed to Albert Einstein the expression, insanity is when you keep doing the same thing the same way and expecting different results. Isn't that mostly what we do? We just tinker? And I've got this thing. I just can't believe you have sitting for exams. I'm sorry, that's so like 18th century British to me. But you sit people for exams. Now what if you suddenly said, let's not do that anymore. Let's make everyone do authentic assignments, where at the end of the semester they have to produce a paper, they have to do a presentation, they have to go out into the field and accomplish something and write a reflection on it. And that's how we'll know how well they learned, how well they applied it to something. Now that's a fundamental different idea about it. Let's say we say people don't learn when you simply feed them content. You lecture them. Let's say you say they have to engage. Well, I'm not saying anything new. This is what we've been saying lately, is we have to turn from passive learning to active learning. And yes, a talented student will learn actively even if just talked at, because they're active in their heads putting things together. Most people won't. They're just memorizing what you're telling them so they can tell it back to you on the exam and be on their way. Overstated, of course. But you get what I mean. You can fundamentally shift the way you think about it. Because if you do research thinking the way you think, you're going to look at certain things you expect to see and tinker maybe. But if you really want to think how to improve what you're doing with evidence, you have to think about what do you think about it first. And that's why this causality is so important. Not just to develop theory, but to actually question your fundamental way of thinking and to think a richer and deeper way you can think about something. So, why is it important? Obviously, you don't want to go sending fewer fire engines to big fires, but mostly so you can figure out what to do about stuff. Because a lot of times we just give me more data. I just want to understand what's going on. Some things are kind of obvious. And so I may be saying, you need to probe deeply and think of theory, but yeah, there may be pretty straightforward things where you've got a procedure you're doing here, you're finding students are not doing what you think, and you look at it and you talk to students and they say, oh, we're not reading the material at all because you said, some things are simple, but the more complicated things aren't. So the question is, how do you establish causality? And the answer is you don't. You cannot prove anything for certain. You can just support it. And the way you support it is with evidence, but actually, more importantly, with an argument. You state, I believe this is the case as to why students who come from rural backgrounds do not do as well in adjusting to college as students who comes from urban backgrounds. I believe it's because, and you fill in what the reasons are. Did they not get as good an education? Were they not prepared to work in a dense environment? Were they not exposed to competitive schooling? It was more cooperative, and this is now competitive. I don't know. You fill in the blanks as to why you think. And I bet you do think. Does anyone want to answer why? What is your honest opinion if we just ask why? You must have thought of this before. And now maybe you don't want to say it because you're thinking it's, I don't want to say it. There's no foolish ideas, just foolish people. No, but what are the reasons people think that people from, well, first of all, people think that people from rural backgrounds have a disadvantage compared to people from urban? Is it about the amount of free space around them? What is it about?
Moving towards a highly technologized world, you make the assumption that because somebody comes from the rural background who isn't exposed to this kind of development will sort of fall behind. So rather than basing it on, core human values, the core human development, where you find that they're probably more grounded to their surroundings around them and can cope with that, with having the same skills, skill set as somebody from an urban background.
So the environment, they're shifting from one culture where they operate a certain way to another culture where they have to operate differently, where the people who come from an urban environment don't have to make that switch. Is it also related to socioeconomic class? Do rural people tend to be from a lower socioeconomic class than urban people? And with socioeconomic class, you have things like cultural capital, Bordeaux's idea, that, the parents didn't go to college and they don't know what it is, what you have to do in college, and they don't have resources. First you have to take care of your basic needs like food and shelter. And if you don't have that, that's a problem. Although that might not differ between urban and rural. Maybe your urban students have that same problem. But it's this kind of thinking, digging into what the causes are. So there are generally two ways to establish causality in social sciences. And one is the logical way. It's your reasoning. And that reasoning can be judged according to quite a number of criteria, and it's very disciplinarily specific. But for many of you in this field, you're going to be working in that realm, where you're using logic and you're thinking, well, if I think this is the cause, then I should see that this is correlated with this, or this makes a difference. Students who are in this program do better than students who are this. So you have that, but then how is that program working? How do you think that program works? It works because it exposes students to the new culture in a friendly way. So that's what you have to find out, if it did that. So it makes you look for different things, not simply that there is a relationship. In research design, that's what research design is all about. It's all about trying to uncover explanation. And research design, probably all of us, or many of us, have taken research design courses from different disciplines in different ways. It's all about creating a scenario that allows us to determine whether our explanation is working. More and more people are going into science without an explanation, just a question. So we'll talk about exploratory data analysis later. But right now we're going to focus on this idea of what's the best way to use these methods to uncover causality. So logically, there's this idea of how sound is the basis of your argument. And this is a parallel. There's something in law called the reasonable person standard. Would a reasonable person in a reasonable job in a reasonable place think that? So how well does your idea compare with what people tend to think? That's obviously not infallible by any means. There's a temporal order. Something cannot cause something that happened before it. And that's why we do these things like test, teach, retest. Because if you had a before measure, and then you do something and there's a change, you can say there's a decent chance that that change was related to it, although you don't know for sure. So temporal order, that's my favorite reverse temporal order phenomenon, that parents inherit insanity from their children. Correlation or expected differences. Well, that's where we said we know correlation is not causation, but if embedded in an argument, if we think something is, if our argument says we should see that these are correlated, that's different. That's support for the argument. So correlation is necessary, but it's not sufficient. It is part of the array of techniques you're using to support your argument. But the biggest thing is this thing called a lack of spuriousness. And this is it. This is the $64 million question. So let's go a little more into spuriousness. It is true that pool drownings and ice cream consumption are positively correlated. It is a fact. The more people eat ice cream, the more people drown in pools. The reason is because they're both a function of hot weather. As the weather gets hotter, more people eat ice cream and more people go swimming. And so that is a classic spurious correlation. They're both caused by the same thing. Then there are things like moderating or conditional effects and mediators and indirect effects. A moderator is the relationship, and I looked this one up, it's true. The relationship between obesity and smoking differs for males and females. For males, obesity leads to less smoking, and for females, it leads to more smoking, if I have it right, if I remember it correctly. It's not important. The important is there really is a gender interaction, a gender moderation going on here. So also called a conditional effect. And this is like when I was talking about risk before. If you have a high-risk student, chances are what you do for them depends on other things about the student. If you give a good student risk information, they can very well, it depends who, I mean, there are more conditions, they are more likely to benefit from being told they're not doing as well. If you give a poor student risk information, they're more likely to withdraw. It's going to just shut them down. So that's a conditional effect, a moderated effect. And this is why human behavior is so complicated. There are all these moderating and mediating. Mediating factors is a mechanism through which something affects something. So education is related to higher spending. Higher education, people spend more. Why? Because they have more income. Because education leads to higher income, which leads to more spending. Now, is this true for every person in every situation? No, of course not. These are human phenomenon, and so there's a distribution around it. There are people who exemplify the rule and people who don't, who are contrary to the rule. In some situations, it's more true than not. In some situations, the rule is weak and doesn't really cover people well. It's a more variable thing. So, the way we go about our inquiry relates to how we can define what we're doing. So the gold standard for causality is randomized experiments. That's where you have an intervention. You want to see if a summer bridge program can profit students who are accepted with lower than desired credentials. So you create a summer bridge program, and students go through it, and how do you tell if it works? Well, the best thing you can do is take a group of 100 students and have 50 of them randomly assigned to the condition of going through the summer bridge, and the other 50 don't, control group, and then you see how they do. And that's the gold standard. Or you do treatment A versus treatment B in a control, or just treatment A versus treatment B. Are any of you doing randomized controls in the things you're thinking about looking at? It's great if you can do it. In higher ed, we tend not to do it because we also feel things, I think I have it on the slide, I'll wait for that. But the other things are these new rising forms of advanced applied regression analysis, quasi-experimental methods. Now, some of you may engage with that, or some of you may get support staff who can engage with that. So I don't expect that everyone is going to go and do any of these things, but it's the idea behind them that's important. How is it that they try to tease out causality? And how can I do something not quite that, but maybe like that when I'm just doing exploratory data analysis? So we'll look at these 4 methods just to give an idea of what they are. So randomized experiments, we've got the representative samples randomly assigned, pre-test, baseline, post-test, treatment and control. So there are different types, different people in the conditions, independent samples, same people in 2 conditions, first, second. mix which order they're in. Those are repeated measures. We can even get people who we think are similar to each other and do what are matched pairs. So they're sort of like people who are the same, but it's somewhere of a hybrid. We may have many conditions by our factors, and so we may have 16 cells to fill, but we don't have enough people, so there are ways to do randomized blocks and Latin squares and other designs. That's all the technical stuff. It just means it gets complicated, like everything. Our problems, as I said, samples are often not representative. For something, the selection occurs somewhere along the way that really changes who's involved. And the ethics issue. This used to be an excuse a lot in higher education. Well, we can't have an intervention and not make it available to everybody. That would not be fair. What if it doesn't work? What if it does harm? More and more we're realizing, it's not a bad idea to try it on some people with a comparison group, see how it works. Not only that, I may have to do it a few times before I can figure out how to do it well, before I adjust it. So there's a lot of learning, and it doesn't necessarily hurt. And in fact, if you can do it, if randomized process is possible in any way, it's the most effective way to tease out causality. These people are the same, except for this group got the intervention and this one didn't. Then we get to these regression-based methods. So we want to see what causes an outcome. Grades, persistence, compliance with a regimen, getting better or being healthier, whatever it is, that outcome. And we have a thing that we think will help. This is our target that we think might be something that's good. And then there's a whole bunch of stuff we need to control for because we know they're related to the outcome. And we want to make sure they're not causing the outcome, so we put them in the same statistical model because that's what regression does. I think it's cetus paribus. Sometimes I get it wrong, and the inverse means something like a sea monster. Right? Cetus paribus, anyone got their Latin? All other things being equal. For this, if two people are exactly the same on all the other traits, what would the effect of this factor be? So that's the idea of regression. The problem is, it doesn't control for what we call selection effects. In other words, you're not necessarily measuring everything you need to control for. And one of that is this selection thing. You have a summer bridge program, and it's open to students who are admitted a certain way, and some students opt for it and some students don't. There's something about the students that opted for it just by opting for it that makes them different from the others. This is the biggest problem we have with verifying programs. This is why every program works, because the better students come into it. They'll self-select into it. This is why support programs are very good, I have to think your language, of changing a 70 to an 80 mark than a 40 to a 60. Because the better people generally take advantages of the supports to improve their marks, whereas the people who are more marginal tend not to do help-seeking behaviors and benefit less. So that selection effect is the evil part of doing work, this observational kind of research. So the people who seek help, the students who seek help, are not a random sample, even when you control for the background, but you need to control for the background still, because that does affect the outcome. If you don't control for matric points when you're studying first-year GPA, first-year marks, sorry, language sometimes go back, then you can't tell if anything else is happening because the high school marks or the matric points are very highly correlated with first-year marks, or pretty highly correlated. So how do they do that? The most popular method these days is propensity score matched samples. And it's an interesting idea. What you do is you first predict who will come for the treatment. What's the likelihood that this student, given the people who went in the treatment and the people who didn't, can I create a predictive model as to who will come and who wouldn't come? And that prediction is a propensity score. This person was very likely to come, and they came. This person a little less. And the more likely you were to come, the more likely you came. But you did get some people who weren't predicted to be likely to come, but they came anyway. So each person has a likelihood that they would come among those who came. And in the people who didn't come situation, you match them with someone else who has that same likelihood. So you create a matched sample based on the likelihood that they would have sought out the treatment, based on your model. And then you just compare the outcomes of the two groups, straightforward, head-to-head comparison. So I have a summer bridge. I get 50 students came. Among the 300 who didn't come, I find 50 who are just as likely to come based on that model. And then I look at the end of the semester and I say, how did the 50 who are in it compare in their marks to the 50 who weren't in it? Straight means test between the two. That's why this is popular, because it's very intuitively appealing. It kind of makes sense. It makes much more sense when you find the people who come are different in some characteristics than the people who didn't come. They have higher matric points. They are more likely to come from a higher quintile high school. They are more likely to have a college-educated parent. And then when you do the matched sample and you compare them on those characteristics, there are no differences. They have the same likelihood as coming from a quintile 3, 4, 5. They have the same likelihood that their parent is a college graduate. So you see the background differences disappear and you feel comfortable. Working on a paper now where we use some machine learning languages ways to generate the propensity sample, and they produce better outcomes, but they don't get rid of the differences as well. Funny. Just complicates it, so I won't tell you what I meant by that. There's also a technique called doubly robust estimator these days that actually combines the confound model with the propensity model and runs the data through both ways, so it's very compelling. Other ways, there's another thing called regression discontinuity, and that's the one that's most similar to a natural experiment. Let's say you have a matric point mark that determines whether a person gets into a program or not. So everyone above a 60 or below a 60 goes into the program. And so therefore you look at the people who are right below the threshold and the people right above the threshold, and you track them and see how they do. Because that's where the difference should make a difference. So it's by looking at those people just above and just below the cutoff that you're able to make a more likely or more confident conclusion about whether the program works. Another interesting one is this instrumental variable approach. So you know that smoking is negatively related to health outcomes, but is it because smoking leads to the negative health outcomes, or is it because it's a lifestyle associated with smoking? People who smoke tend to do other things that are high-risk behaviors. Diet, exercise, or lack thereof, jobs, whatever. How can you tell? Well, if tobacco tax is an instrument, is correlated with health such that as tobacco taxes go up, smoking behavior goes down and health outcomes get better, then you could kind of be sure that tobacco is related, because tobacco taxes affect smoking behavior but not the rest of the lifestyle choices. So that's called an instrumental variable approach. And this is the kind of thing you can do logically. You can find something that you know is you expect, and it's not easy to do these things, but you need to think of this for your project. It'll be correlated with the behavior I'm looking at in terms of its influence on the outcome, and it'll kind of weed out the other behaviors that may be confounding things. Then another fun one is a difference in differences model. And this is where you make a change in what you do, make change in practice. So starting next year, we're going to take all students who have below a certain matric point level, and we're going to put them in an access program. Let's not do an access program, because that's taking them out of mainstream. We're going to give them supplemental instruction. So they're doing the same thing as the students used to do, except they're adding something to it, supplemental instruction, where they get help for their courses outside of their courses. So you look at the students last year who would have been the people who would have been given the treatment had they been here this year, and you compare them a year later to these students a year later. So you're seeing, in effect, if the addition of the treatment makes a change in the behavior. So that's a difference in differences. So I'm sure all of you understand now what I mean about causality. Before we go on to the next part, let's think a little bit about your own tasks and causality. So have any of you, while you're sitting here, thought within your own project what your reasoning is behind why you think what's happening is happening? And if so, could you share? You're nodding your head, so I'm picking on you. Yeah.
I research topic is on exchange rate pass-through to domestic prices. Now, in the empirics, it has been, many people have opined that fluctuation in exchange rate pass-through to domestic prices at different rates in the developed countries. While it is low in the developing country based on they are dependent on import and all that. But looking at what you have just explained now, I think it is necessary that you should just base our conclusion on the fact that it is fluctuation that actually leads to the pass-through.
I'm sorry, it's what that leads to it?
Fluctuations in exchange rate that actually affects the domestic prices. Mm-hmm. There could be other factors. And that, I've just seen now that it is necessary that we go beyond just looking at that causality. We should look at these interactive variables, like what you called...
a moderator.
Yeah, a moderator to actually be able to have confidence to draw a conclusion. I think that's very, very reasonable. And
great. Yeah, and by the way, moderator is the language used in psychology. It's not, different languages are used in different disciplines, but like conditional effects might be more common in economics, I'm not sure. Interactor factor, yes. That's a more generic term. That's used in psychology too. Any other good examples of causality in what you're looking at or what you're planning to look at?
There was a study we did. Actually, literature says that over 50 to 60% of persons, men who are infertile, consume alcohol, and so somehow they feel that alcohol causes male infertility. But we've done some studies using animals, and we realized, okay, alcohol actually induces male infertility in animals. And but we did a study again using questionnaire basis, and we realized that a lot of persons who consume alcohol, in fact, have 5, 6, 7 children. And so it's as if alcohol is not causing male infertility, but in the fertility clinic, it's as if alcohol is what's causing infertility.
No, it's infertility that's causing alcohol use. You had it backwards. What's the lifestyle cluster associated with infertility? Does the environment you're in, a little more toxic environment, or does your diet differ? Does that influence infertility and influence alcohol? Or, in other words, I can think of so many possible reasons why both could be related to something else. And if I knew you feel better, I'd give you better answers. Yeah.
So I'm beginning to wonder whether, in fact, when we're talking about correlations, whether we would be really looking at association amongst factors rather than a causation.
Depending on whether you had the idea before or after. So if you're specifically looking for something and you look at a correlation, you have causation in mind, and it's a piece of the evidence puzzle. It's not all of it. Then you have to see, well, it could be something that's causing both. Or it could be that's immediate. So there's so many ways it could happen. But if you're looking at it in the context of an intentional design where you're trying to tease out causality, correlation is part of your evidence. But if you're just looking at a correlation, it's just an association.
Because we're using the term correlation, and very often, as you've mentioned, it's linked to causality.
Yeah.
And I think that's the correction I needed in my head.
Yes, you
do.
Thank
you.
We all do. Because even I will occasionally, I'll make the inferential leap in saying, oh my God, look at that person who's doing that. That must mean that, and I'm thinking that there's a causal thing going on. So even us people who work with it all the time will slide back into correlation as causality.
You've just made our task very much more difficult in higher education.
Thank you. I mean,
now we can't link many of factors as a cause.
Right.
To poor performance.
My objective is to take your confusion to a higher level about more important things.
Yeah, sorry, it'll take me a bit of time to articulate this, but you've got factors 1 and 2, and you have observations in those factors, and the question is, does there exist some factor 3 that's really the cause of those of the states in those factors? So the question is, in terms of trying to establish this, is it simply a matter of establishing the regression among all the factors? So you could, first you have to think of this factor 3, like with your pool and ice cream, you have to think of the factor of weather as well. So if you've done that, or let's say you are investigating a number of possible true causes, factor 3s, right? Now, is it simply a matter of looking for a better, or would finding a better correlation be an indicator that that is a stronger cause?
Yeah, there's a lot behind what you said. There's issues of exogeneity and endogeneity that they talk about. The things that you're not, exogenous is stuff you're not controlling for. And how is it affecting? There's this one bind in statistical modeling. It says if your model is not correctly specified, if you don't have all the factors that systematically account for change in the outcome, then the coefficients are biased. But you can never have all the factors. You can hope that the other factors are a wash. There are stuff, positive stuff, negative, and overall all the other uncontrolled factors are kind of noise, which is why you get an R-square from a regression, which tells you how much of the variation your model is accounting for. So you get a model that accounts for 25% of the variation, meaning there's other stuff going on that you don't have the factors in there. The question is, are they masking something or being masked by? And there are some diagnostics you could look at to see if that's the case. You look at the residuals and how they're correlated or not correlated or related to. So there are techniques for doing it to see if you're on firm ground. But the whole thing is about always coming up with a better model. So a lot of when you get into statistical modeling, you're saying, I think these are the system of variables that account for this. And someone says, oh no, I think these are the system of variables. And you can compare the goodness of fit of the two models and say this has a better fit. But if we actually understood human behavior, none of us would be here now. So we're always just trying to take it to another level. And we're generally getting better, but as we find out every once in a while, we were completely wrong about something. You know, anyone remember, this is maybe too culturally specific a reference, the Woody Allen movie where he goes into the futures and he finds out that milkshakes and French fries are good for you and spinach is bad for you. You know, everything we thought about diet was completely opposite. It's something like that, but every once in a while, everyone says, oh, no, you know, that's not anymore what we believe. So it's all about improving your evidence. It's never about being absolutely sure you have it right.
We have this covariance matrix. That's a good way of working out what's a better causal indicator. Maybe you can say
among the factors that you're including, but only that's endogeneity. That's only within the model.
Yes, not an indication of causality.
Right. You don't know what you're not looking at about that. That's why this stuff is so frustrating, because you can't get it perfect. You could just get it better.
I just want to find out on correlation and causality. Of course, correlation is not equal to causality, but it merely gives us some evidence, part of the evidence, and often that's the first, if only piece of evidence would have. You would have to prove temporal order and lack of spuriousness. Is there a structured way of one moving from correlation to try to explain causation?
Yeah, and these ways, these techniques, difference and differences, regression, discontinuity, instrumental variable, the 4 I have listed somewhere. These are examples of how you can go to the next level in an observational study, and randomization is a way you can go to the next level in where you have the occasion to be able to put your subjects in randomly. So those are the next level. Now, there's also another level in exploratory data analysis where, so I said the propensity model puts like and like. You can do like and like in a different way. You can disaggregate your population by gender, by race, by age, by metric points, and look at the effect within the different strata. That's kind of like doing an informal propensity model. So seeing if this overall effect, does it hold for different groups? So that's further evidence. If you find, yes, it holds for different kind of groups similarly, then you know it's a more general effect. But if you start finding, no, it's true among low metric point students, but it's not true among high. In most of my research, I find for good students, nothing predicts anything. They just do good, they do well. For poor students, certain things predict and certain things don't. And for middle range students, that's where you see the most predictive power. So you can actually tell that different things, different treatments work differently for students at different parts of the ability spectrum. And I don't want to get into what I mean by ability because we could go on for days about that. Yeah, there was a question there.
What is the language you should be using if you're looking for the effects of a program?
Right, it supports. It supports our argument. It supports our hypothesis. It supports our claim. It's evidence for it. That's it.
All right. Thanks.
Nothing is ever proven in social science, despite what people tell you. They tell you that even more in politics. Okay, let's see where we were. What's next? Okay, so statistical model is one thing, but research design is actually broader than that. It has to do with the way you approach a research, the way you arrange things. And so part of exploring causality is also based on things you do in terms of the overall design of your research. So it's not simply a one-time observational study where you're looking, is X correlated with Y, controlling for A, B, and C. It's more of a setup, and it can be like a randomized trial, test, intervention, pretest. A pretest, intervention, post-test. That's a design. It could be a qualitative study where you, and this is my weakness, I am not a qualitative researcher, so I can't give you the best of this, but you take certain precautions. You do things like you establish the trustworthiness of your observations. There are other things, member checking and trustworthiness, and all these things you do to try and see if it's not your bias that was creating the results, but it looks like it was a balanced approach. So all of these are about accounting for the context, and you have to have a pretty decently thought out idea to go into these to get good information out of it. You also have to be sensitive to the interactions, like different for males and females, because if you think about it, you got 10 variables in your analysis with their outcome, and you try to think of every interaction possible, you're going to have this by this, this by this, you have the 10 by 10 factorial, whatever it is. Then you have all the three-way interactions. Then you have all the four-way interactions and all the five-way interactions. And you cannot do a full model with all the interaction terms. It just eats up your degrees of freedom. So you have to choose interactions based on what, the literature, past literature, the logic, or things like that. But it's about, as best as you can, specifying what you think the model looks like, what factors you think are necessary. It's also about the rigor and the steps you take. So if someone else tried to do it, they could tell if it worked the same way, replicability. So with quantitative studies, we have data collection, because somehow we're going to get empirical data. Some of that is, more and more, we're using extant data. This is where what we call big data sometimes comes in. People leave a lot of electronic footprints behind. We collect data in our information systems. We'll talk about that more tomorrow. They use our courseware system. With activities, they tick their card, their ID. We count how many aspirins they take in the hospital. We count everything we do to them. So there's a lot of data that's left behind from the operational stuff. There's also national data sets. If we want to know where someone is from makes a difference. I don't know how it is here, but in the US, you have all this place-related social data, poverty rates and density and educational outcome, access rates. So you have information about where they're from that is extant. Or we have to collect data, surveys, laboratory instruments, other type of instruments, questionnaire, examinations, whatever way you pull the data out of the students or people. So those are where the data come from. Then we have experiments, and you can actually have experiment where you're using extant data. So you're looking at how students who travel who have to leave a certain class to get to another place, what paths they traverse. And you randomly put barriers in their way that they have to go, or something like that. And you can watch and record. And so there's ways to do experiments even with observational data. That actually would be a collection. I guess once the data is collected, not much you can do about randomizing, except randomizing your selection, of course. But experiments usually involve the collection of data. Then, for eons, until data analytics came along, people were using all sorts of statistical methods. And it hasn't been that long that we've been using statistical methods like this. 1930s, 40s, Pearson, Fisher, those guys started, even back. Student was, I think, which Gossett was his real name, but student t-test and all that. He was a brewer for Guinness in like the 1920s or something. It came up. But they didn't have the computational machinery to do the kind of statistics we could do now, because everything had to be done by abacus and more primitive technologies. So statistics aren't really that old, but now we can call it traditional, where it is done to explore generally hypotheses, where we think why it's going to go on and we check and see if it does. Also with things like intervention assessment, where we say we have a program, we want to do a program evaluation. There are many methods, qualitative and quantitative, for doing that, but we want to see what's happening. So there are techniques we build around an intervention assessment. And then this idea of statistical modeling, where we say we think this is what's going on, we collect the data, we match it to the model, and see how good or poorly it matches. So that's the general way we go about designing these studies. I'm not doing this justice because design, it takes a while to develop. But my point is to give you the flavor of this, and also then on the qualitative side, where we use qualitative methods for understanding how people experience things, for ethnography, describing culture, historical, case study, grounded theory, and so on. Different ways where it's not as important generalization is not the goal. The goal is to understand richly the context in which we're working in. But it's also to find out more about why things happen rather than what happens, which is why sometimes it's good to put the two of them together. And now you have the mixed methods, which every grad student who says, I'm going to do a mixed methods design, most faculty say, don't. Pick one and go with it. It's too hard to get the faculty to agree when you do a mixed methods. But it actually is triangulation. It actually is where you're using one way to select the other. And Creswell from either Michigan or Michigan State, I always forget, has his 6 designs just as an illustration that you can do them both at the same time, bring them together and interpret. Or you could do quantitative, a survey, and then go back and do qualitative and talk to people about what you found out and what does it mean. Or you can do qualitative, like finding out what language people use to talk about this stuff, and then create a survey. He's got 6 of them. Quantitative or qualitative design, quantitative data collection, and then nested within it is another design before, during, after, and then you interpret, and then he's got this transformative, quantitative, follow up with qualitative, interpret, and so on. Anyway, so there's different ways you can put these methods together, but they're all about really using different approaches. But now, what you're really talking about here is more in the realm of what we call exploratory data analysis. Let's see what the data say. And I want you to be critical of this as you do this, because there is a tendency when you talk to computer information science people to focus too much on the data rather than on the meaning. But the meaning is critical. But exploratory data analysis is not a bad thing. It's a good thing. You don't know enough about something to conclude. You're building up your ideas, and so you kind of can look. There's patterns. There's relationships. Then you have to get into what's going on here. So typically, these kind of studies lead you to want to do some more traditional approach to research to find out why, because they tell you what. But there are ways to use exploratory data analysis and disaggregate and look at it different ways if you have a good sound basis of logic to try to get at causality. And often people will see a pattern raised by this and then just start talking to the people who are in the system, the students, the patients. And they'll start getting a sense of things. And if they bring together people who may look at it differently and say, you know, I don't see it that way. I think what happened here is this. And if you start getting those rich conversations going between people, it's actually a good substitute for one person just going on and researching something until they know so much about it, but their beard is this long, and that they get so personally into it without getting socially into it. And in effect, you could even think of a qualitative phenomenon, situational learning, to understand that what you are researching with and what you are looking at is important, just as important as who you're researching it with. So if you're in a school situation, you want instructors, you want support staff, you want managers, you want them all to be part of the conversation. You need to get the voices at the table. If you're in a hospital, you need patients, you need doctors, you need nurses, you need physical therapists. All the people who look at it from a different angle. And that brain power will help you think more richly about it. Of course, it could also lead to groupthink, so it's not always good. Okay, we're getting down to the end here. So the takeaways I hope you get from this are that causality is really important, but not easy to establish. In fact, you can't really establish it. You could just find evidence for it. That formally it requires theory-informed research design and analysis, appropriate analysis, but informally it can be supported with thoughtful descriptive analysis, and that should say among people with diverse perspectives. We'll add that later. Okay, that's for another time, I think. Research questions. We're going to do that later, right? We'll find out. Anyway, let's stop with that here and open it up to your thinking and your ideas about moving forward, because after this, we're going to move into them starting to work on their problems. Randir, you may be good at segueing this.
Not all research is aimed at establishing causality. So, for instance, if I want to build a reactor, right, I can definitely work from the reaction mechanisms, and I can develop a detailed model based on my fundamental understanding. That's one thing. But I could also do that by just regressing out rates for things and just finding the mathematical form of things. And equally, I can build that reactor. So
mathematical form of things is causal.
Well, then that's not what I meant. As long as I have the numbers I need that tell me what the rate is going to be, I can build that reactor. Now,
okay, but how's that research?
So some research involves what's the best way of building this reactor. So what's the optimal size for this reactor? So it's a different type so it's not always the case that research involves causality, especially for profession-oriented fields like engineering.
And I grounded this in social science, but I think what you're talking about is calibration.
No, I don't think so. It has to do sometimes with, you see, we do have all the mechanisms and Navier-Stokes equations and all